I'm now going to run through the 3-pointer, the 4-pointers, and the 6-pointer from the Common Core exam, and we'll see how you guys did. Look at this first one. Solve the systems. What we need to do is take the easier, which is definitely the bottom one, and get y or x alone. It's up to you which letter you want to get alone, and then substitute it into the top guy. Totally up to us. How about we get the x alone? All right, so I'm going to subtract the 2y over. You could have done it the other way. We're going to get the same answer. 2x equals negative 2y plus 10. Or you could have put 10 minus 2y, totally fine. Divide everything by 2. So I get x equals negative y plus 5. Okay, now that I have that, I'm going to plug that in right there because that's where we have an x. So now I'm going to do negative y plus 5 minus 3 squared plus y plus 2 squared equals 16. So this parenthesis becomes negative y plus 2 squared plus y plus 2 squared. All right, everybody, I said this 100 times this year. Squared means write it twice. So here we go. Negative y plus 2. Negative y plus 2 plus y plus 2, y plus 2 equals 16. All right, and this is where I like to do the brackets because I'm going to put all this work in here plus all this work in here equals 16. Okay, so I'm going to distribute. Negative times a negative becomes positive y squared. Negative y times 2 is negative 2y. Do this one, negative 2y. And 2 times 2 is 4. Okay. Now I'm going to do these guys, put them in this bracket. Y times y is y squared plus 2y plus 2y plus 4. Okay, so in this bracket, I have y squared minus 4y plus 4. Plus this becomes y squared plus 4y plus 4 equals 16. So now let's combine like terms. I have 2y squares plus 8. Right? These guys went away. Equals 16. All right, there's a squared in the problem, so I'm going to set it equal to 0. So I'm going to subtract the 16 over to the other side. So I get 2y squared minus 8 equals 0. Hey, I'm going to divide everything by 2. So I get y squared minus 4 equals 0. That factors into y plus 2, y minus 2. So I've got two different y's. Y equals negative 2, y equals positive 2. Now, this question used to have x's in it as well. So what you do now is you take this and you plug it into your x equals equation. So x equals negative 2 plus 5. So x equals 2 plus 5, which is 7. So that makes the point 7, negative 2. Now we're going to plug 2 into this. X equals negative 2 plus 5. So x equals 3. So that makes the point 3, 2. And these are the answers to the question. So again, you could have solved and got y alone, and you would have ended up with the exact same answers. Okay, next one. Alexa earns $33,000 in her first year of teaching and earns 4% increase each successive year. Write a geometric formula. All right, so I'm going to make some lines just to get myself started. So the first year, right, she makes $33,000. Now she's making 4% increase. That means we're doing 1 plus 0.04, which makes 1.04. That's how much we're attaching on to each of these. And this one she'll be doing it 33,000, and she's getting that twice, like that. So now we want to write a geometric series formula for Sn. All right, that's actually a formula they give us. I'm going to pull up the formula sheet. If you see here on the formula sheet, this is the formula. So I'm going to write that down. So I get Sn equals a1 minus a1 r to the n all over 1 minus r. All right, so I just got to start plugging into that. Sn equals, a1 is the first one, 33,000, minus a1 again, 33,000. R is whatever we're multiplying by, so it's 1.04 to the n all over 1 minus 1.04. And that's it for that portion. That's all you had to do there. Use this formula to find our earnings after 15 years. So that means they want us to plug 15 in for n. So 33,000 minus 33,000, 1.04 to the 15, all over 1 minus 1.04. Okay. So basically, this is worth 2 points. That's worth a third point. Now it's your job just to get into your calculator right. So let's see here. 33,000 minus 33,000, let's see, 1.04 raised to the 15th, enter, divided by, and then parentheses, 1 minus 1.04. So I'm getting 1 to the nearest cent, so I'm getting 660, comma, 778.39. There you go. And that's the answer to the question. And this was the answer to this part. All right. Now let's say you completely butchered this, but you plugged in 15 right into whatever you came up with. There's partial credit to be had all over the place. All right. Now this one we had done the day before the test, so I was kind of hoping you guys remembered how to do it. 55 students attending the prom were randomly selected to participate in a survey about music choice at the prom. 60% responded that a DJ would be preferred over a band. Members of the prom committee thought that the vote would have 50% for the DJ, 50% for the band. Okay, simulation was run, sample size 55, based on 60% students. Normal, well, that's our curve, results in mean, all right. Using the results of the simulation, determine a plausible interval containing 95%. Okay, 95% means we're doing 2 standard deviations. So this is where you draw your curve, because they said normal. The mean goes in the middle, so there's our mean. So that's 0.602. The standard deviation up there is 0.066. Well, since they said 95%, we've got to add on 2 standard deviations and take off 2 standard deviations. So I go to my calculator, 0.062, and I'm going to add on the standard deviation twice. And that makes 0.734. And then I'm going to go the other way and take the mean and subtract it off twice. 0.47. Okay, so round all values. Okay, so my interval is 0.47 to 0.73. That's it for that one. Okay, next part. Members of the prom committee are concerned that a vote of all students attending the prom may produce a 50-50 split. What statistical evidence supports this concern? Well, this 95% means we are 95% confident that the result will fall between 47% and 73%. Since 50% falls within this interval, it is very possible of happening. And that's all you had to do for that part. Write that sentence. All right. We're almost done. Which function shown below has the greater average rate of change, which just means slope, on the interval -2 to 4? Justify your answer. All right, so we need the slope where x is -2, so I'm going to use that point. And 4, which means I'm going to use that point. So let's see here. The average rate of change for f of x. All right, so I'm going to do that work below it. Now, average rate of change, actually, I'm going to do this. y2 minus y1. Right? So we're going to do 80 minus 1.25 over 4 minus -2. So let's do that. Go to Mr. Calculator. So 80, if you can see it, 80 minus 1.25 is 78.75. And 4 minus -2 is 6. So I just got to divide this by 6. And I'm getting 13.125. So that's the average rate of change for F. So now I got to do this for G. The thing is, they didn't give us a chart, so we actually have to come up with our own answers. They gave us -2. So what I'm going to do is plug -2 into this pattern. All right, let's see what we get. Let me clear that up. So I've got 4 -2 cubed minus 5 times -2 squared plus 3. I'm getting -49. Now I'm going to plug 4 in. So do 4 parentheses 4 cubed minus, oops, delete that out, got to get out of there, minus 5 times 4 squared plus 3. Getting 179. So now I have to do the average rate of change of Gx, which means I'm doing 179 minus -49 all over 4 minus -2. So the bottom's still 6. 179 minus -49 is 228 divided by 6. And I'm getting 38. All right. Which function has the greater? So g of x has the greater average rate of change. All right, so that should have been the answer for that one. One more, the big 6-pointer. Let's see how we did on that. Lottie did a lot of work for this one, so let's see how it goes. Drugs break down in the human body at different rates, and therefore must be prescribed by doctors carefully to prevent complications, such as overdosing. The breakdown of a drug is represented by this function. Okay. Where n of t is the amount left in the body, n sub 0 is the initial dosage, r is the decay rate, and t is time. All right. Patient A, which we're going to call A of t, is given 800 milligrams of drug. So that means the original amount was 800. E, the decay rate, so we're going to do -0.347 t. Okay. Then B of t, they were given 400 e to the -0.231 t. Boom. So right there, you didn't get a 0. Got some points. Now, graph each. Now, let's take a look at this. We know I have to start at time 0. Looks like we can go out by ones. 1, 2, 3, 4. Let's make this 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, wait, 11, 12, 13, 14, 15, 16, 17, 18, 19, so we'll make that 20. I don't know if you can see this, hold on a sec. So when I did this, I just went out by 5s for t. And then we have to go up to 800, so it looks like I can do every 2 boxes is 100, 200, 300, 400, 500. Okay. Now I'm going to go graphing calculator. I'm going to do 800. I'll put the first one in. E to the negative 0.347x. And then I'm just going to go to the table. And I'm going to write these down. Let's see, starts at 0. So here, I'll put them over here. This is going to be A of t. And I'm kind of making an XY chart. And it looks like 0 is 800. 1 is 565.44. 2 looks like it's 3. I'm just going to copy these down. 4 is 199.66. 5 is 141.12. You could do every other one if you want. I'm starting to get bored, so I probably will. Let's do 6. I'll do 8 is 49.83. 10 is 24.894. I mean, if you put them all down, you're there for 3 hours. So that's always better. But even if you just wanted to do every other one like I'm doing, is fine. 6.2128. 16 is 3.138. 18. 1.55. If you notice, it's asymptoting towards the 0. That's what's happening here. 0.77462. All right, so let's graph some of these. So 0 is 800. Boom. 2 looks like it's 400. So I'm going to do that. 6 looks like it's 100. Let's do that. 10 looks like it's just about 25. We'll do, wait. That's 6, 7, 8. Let's do 8 is 50. About there. 10 is about halfway to there. 14 is 6. We're getting smaller and smaller. So what's happening is it's coming down. And then it's asymptoting over here. Like that. Okay. So this is A of t. Now we're putting 2 things on the same picture, so you have to make sure you label. All right, now we're going to go to our calculators and we'll make an XY chart for B of t. And I'm just going to do every other one like I did last time. So here we go. Y equals, I'm going to clear that out, 400 negative 0.231x. Go to the table. And I'm just going to go back to 0. Okay, so 0 is 400. I'm just going to do every other one. 2 is 252.01. Oh, but look, 3 is a nice number. Anytime you see a nice number like that. 3 is 200. That's a good one. 4 is 158.77. 6 is 100. That's a good number. Let's see. Oh, look at 8 and 9. So I'm going to put down both those. 8 is 63.021. 9 is 50. 10 is 39.705. 12 is 25. Again, you could have written down all of them. 14 is 15.76. 16 is 9.929. Let's do 18 and 20. 18 is 6.22. Whoa, 2555. And 20, oops, 20 is 3.9. All right, so this is what I did. I wrote them all down. I know my paper keeps moving. Sorry, guys. Oops. Okay, so I'm going to plot these points. 0 is 400. 3 is 200. 1, 2, 3 is 200. So I'm going to do that. And you can plot all of them if you want to. 6 is 100. Whoop, look, they basically hit in the same spot. 9 is 50. 12 is 25. 10, 11, 12 is 25. And let's see. 16 is 10. All right, so this is going to come down. And it looks like it's a little higher. All right, so this is b of t. So your graph should look something like that. Okay, so up here, to the nearest hour, t, when does the amount of the given drug remaining in B begin to exceed the amount, well, as seen in the graph, you have to kind of explain where you got the answer from. B of t, B exceeds A starting at t equals 6. So that's that one. And if you want to see what I'm talking about, right here at 6, they kind of hit, and then B's higher than the A graph. All right, last part, here we go. The doctor will allow patient A. All right, so let me write down what A was. A was this guy, to the negative 0.347 t. A, to take another dose once 15% of the original amount is left in the body. Determine to the nearest tenth of an hour how long patient A will have to wait. Okay, so first off, we need to know what 15% is of 800. So I'm going to do 800 times 0.15, and I get 120. So I need to know when there's 120 left. Hey, there's a letter in the exponent. This is a log question. So you're going to start off by dividing by 800. So I'm going to do 120 divided by this, and it's 0.15. Did it in my calculator real quick over here on the side. Now we're going to log it, but we're going to use the natural log. So I get the natural log of 0.15. Got the negative there. Negative 0.347 t. Natural log of e, and hopefully everyone remember that's the number 1. So you don't need to write it anymore, right? I'm going to divide by negative 0.347. That cancels. So t equals natural log of 0.15 divided by negative 0.347. And the answer is going to be 5.5 for that one. All right, guys. Voila! This was the entire test, so I hope you did okay. We'll have the scores in about a week or so.